Very good evening, colleagues, friends, alumni, students, guests. I'm Professor Donald. I'm Interim Vice Chancellor, and it's really a great pleasure to welcome you here to this inaugural lecture, which will be presented by Professor Kirsty Donald. Very warm welcome also. I know that there are members of Professor Donald's family here. Wonderful to have you here on this occasion. We have the platform party here, and I'll introduce my colleagues, starting closest to me, Professor Lionel Green-Thompson, who's the Dean of the Faculty of Health Sciences, our inaugural lecturer, Professor Donald, Professor Graham Fegan, head of the Neuroscience Institute, and then two of my Deputy Vice Chancellor colleagues are with us, Professor Sue Harrison, Deputy Vice Chancellor for Research and Innovation, and Professor Harsha Kathad, who is the Acting Deputy Vice Chancellor for Teaching and Learning. So very warm welcome to you as well. So ladies and gentlemen, inaugural lectures really are a special event in the university calendar. A full professorship really is the highest academic rank, the highest rank to which an academic staff member may aspire. The appointment process to that rank really constitutes recognition of the stature of the individual, the fact that they are leaders in their field, that their work has been of the highest quality, whether it's been research or teaching, learning, or social responsiveness. The process leading to appointment or promotion to the rank of full professor is, I can tell you, it's an arduous one. The criteria are stiff, and so it really means something when somebody achieves that rank, as our lecturer this evening. So, inaugural lectures celebrate the achievements of the lecturer. They present us with an opportunity to hear what the person has to say, what they profess. So, by the way, I thought I should find out what exactly does it mean to profess, you know? What does it mean to be a professor? Well, the term goes back to the affirmation of one's faith in religion or a set of beliefs. But in our context, it really would mean somebody who claims knowledge, has the knowledge to be a leader in their field and to be able to, shall we say, proclaim it publicly. And so it is in that context that we will be listening to our lecturer tonight. There'll be no doubt amongst any of us that the domain of research of Professor Donald is one that will be of interest really to the widest possible audience, given her background and expertise in the domain of pediatrics, broadly speaking. The idea also is that an inaugural lecturer should present their work, should profess, if you like, in a manner that is accessible to a broad audience, and I've no doubt that that will be the case this evening. And I did say to Kirsty, you know, this is a celebratory occasion, so enjoy it, huh? Well, it gives me pleasure now to call upon the Dean of the Faculty of Health Sciences, Professor Lionel Green-Thompson, to introduce our speaker. Thank you.
Wamkelekile apa UCT, Endao UCT Neuroscience, the place of the stars. This is what the first people who lived in this place called this place. They recognized it themselves at that time already as a place of wisdom and enlightenment, a place where they gathered herbs and plants for their healing. Here on the slopes of the mountain they call the Hurikwaha Mountain. Today I take the posture unashamedly of the Mbongi, the praise singer who celebrates the one to come after them. And I say, Siti Halala, Professor Donald Halala. It is in this place that I'm called to introduce to you Professor Kirsty Donald, an academic clinician, an engaged scholar, a clinical translational scientist, but also a practitioner of social accountability. I'm also drawn as the Mbongi to say, Igama lamakhosikazi malibongwe. May the names of the women be thanked for the work that they do. But welcome especially to the family, to Mary Bell, Kirsty's mom, and to Rob, her husband, and their children are here as well. So welcome to you, because we recognize the extent to which we share this gift with you, and the extent to which in many ways you have to give her up to us ever so often. Professor Donald was promoted to full professor in 2019 already, on the basis of the outstanding achievement in the 4 areas considered by the faculty and the university: learning and teaching. Her head of department at the time called her a clear and effective teacher. On the basis of research, when I checked earlier, it's over 120 articles, multiple chapters and technical reports, an H-index of 34. About 10 of her articles have been cited by more than 100 people, and 3,600 citations in all. For the gifts of leadership and management, but also in social responsiveness. Kirsty Donald graduated with a PhD in 2015, following her qualification as a subspecialist in pediatric neurology, both with an MPhil and in the certificate from the Colleges of Medicine of South Africa. She had earlier been awarded the fellowship of the College of Pediatrics in 2006. But there are a couple of things I wanted to highlight from the CVs. So I reckon you could get all of these on the internet if you tried. But I'm going to try to craft a little bit about the story that I see in the CV that Kirsty has offered. I think it's not an accident that the title includes the idea of context, because very powerfully this scholarship is this idea of translating what we do as academics into the difference we make in the world. And so I want to just highlight a couple of her contributions, both at the faculty and then to the body of work that she speaks into. She's been in that application for promotion, her head of department said that she has contributed to leading transformation, the processes both at the departmental and the faculty level. But my own personal encounter, having arrived at UCT fairly recently, is really the work that Kirsty has done in the Professional Standards Committee. Kirsty led that committee for some time, but its particular importance is its guidance of us as a faculty in terms of how it is we must be in the world. And it is about showing us how to reflect on our practice, dealing with those who would avoid that call to decent practice, but showing us continually how we can be better. In Kirsty's own words, in her NRF application, she speaks about this genetic and phenotypic characterization of neurodevelopmental disorders, again, in a South African context. The effects of maternal mental health on the development of their infants, the preventable causes of neurodisability, such as alcohol and methamphetamine exposure, and the neurological and neurocognitive complications of HIV exposure and infection. Kirsty is part of a number of significant grants. The Wellcome Leap grant called Kula Leap, a Bill and Melinda Gates Foundation grant on low-field MRI to characterize the impact of maternal anemia, an NIH grant, and the UK Medical Research Council grant as well. But in looking at the documents related to Kirsty's story, there are a couple of quotes that she's made in the documents that I think, maybe she says them again today, I hope not. But growing up in Cape Town, South Africa, my career has been keenly influenced by my experience of many different cultures, living in close proximity. But colleagues, she says, divided by their vastly different historical, cultural, and economic experiences and contexts. It's this kind of scholarship that we celebrate tonight. It's this kind of scholarship which recognizes their own origins and then looks to the differences that our socio-political environment have brought on us. I want to close just with quoting one of the articles that Kirsty has written that has led the writing of, because there are about 10 authors on the paper. The Risk and Protective Factors for Child Development, an observational South African birth control study, recognizing it as one of the few that have emerged from a low and middle income country which speaks to this issue. But the scary thing that they make a note of in the opening line is that approximately 250 million, 43%, of children under the age of 5 years in low and middle income countries are failing to meet their development potential. It's an indictment on all of us scholars. At the end of that article, they say that public health policy needs to work along the continuum from pre-pregnancy all the way to the context of families, ensuring that encouraging safety, security, and early warning in the context of nurturing care. All of what I've seen in Kirsty's work, in Professor Donald's work, I must make sure that I address appropriately this evening, all of her work speaks to this idea that if we are to be socially accountable as a faculty and as a university, we've got to continually ask the question, yes, we are clever, yes, we study things, but the key question we have to ask ourselves, what difference do we make in the world? And from looking at the scholarship that Professor Donald presented, I have no doubt that this kind of work is what makes a difference. And so, colleagues, I welcome Professor Donald to deliver her inaugural lecture entitled Context Matters, Risk and Resilience in Early Childhood Brain Development.
I'm going to tell you a story this evening. It's a story about young children and their development. And as Lionel said, it's about what's important and why it matters. I think children and small children are something that we all feel strongly about. Many of us have children. Many of us have nieces and nephews and siblings and grandchildren even. And we've seen them grow up in that kind of miraculous early period of life and seen them gain skills day by day, week by week, and month by month. And what I'm going to tell you today or explore today is a little bit of something of what happens in this period, both at a kind of neurobiological level and how environment impacts or context impacts that process, both from before the child is born and into early life, with all those important relationships and the job of being a small child. So, to begin, let's make sure I'm getting this right. Okay, so to give you a little outline so you can keep track of where you are and how close you are to the snacks. We've got, I'm going to talk about understanding the development of the human brain, how context matters, especially what we can learn from the African ecosystem. What are the relevant risks to young brains, and how and when do these make their impact felt? What protective factors can support resilience in early life, and how can we learn at scale? So to start out, understanding the development of the human brain. Why do we need to look at early life? What's so special about this early period? So as your brain develops, we have an intrinsic capacity, an inherent potential, which is informed to a large extent by our genetics. But then we build our brain as we are using it, shaping it both by our inherent capabilities as well as iteratively impacted on by the environment, by caregiving and other important social relationships, and of course by our physical growth and health. Brains are not little organs sitting on their own. They are part of a whole being, and those little beings are part of a family and a social fabric, and none of this means anything without that context. Here, you can see that during the very early period of life, in fact, the brain is growing at speed. It's laying down more neurons. It almost gains its adult size at 2 years of age, and certainly by 5. Although we do keep on growing our brains beyond that, it is more in the process of pruning and efficiency as we get older. So, and that is really where the impact of your environment and your interactions play a role in who you end up being in later life. So it's a complex interplay between your inherent potential and your genetics and the environment in which you grow up. So to be our best selves, we definitely need the best foundations. Here, I'm just giving you a little window on the sensitive periods that we have when we are growing and developing. So you can see that the period before birth is a critical part of the laying down of the sort of structural foundations of your brain. But the skills that you gain in that first year and a half is very tightly packed into windows of opportunity. First, the sensory window and the language window and higher cognitive functions. It's not that those windows are closed, but just that the greatest gains happen and the sort of foundational networks get put in place during that period, which is an amazing opportunity, but it's also it also puts children at potential risk if they are not in the right kind of environments with the right kind of relationships and caregiving for developing those skills to their best potential. I'm going to come back to this later, because in trying to understand it, we need to get at these areas. We need to be able to try and understand what's actually happening in the brain during those periods for those particular skills in those windows. Again, thinking about context, it's not something which happens at one time. Your context is a sort of a rich matrix of things which your mum may be exposed to during pregnancy, and which you will to some extent continue to be exposed to through your early life. So this can be obviously your parenting. It can be your mum's nutrition in pregnancy, which is really important, your nutrition as a young infant, breastfeeding. The microbiome, which I will speak to a little bit more later, is an important reflection of your environment. Sleep is becoming very well recognized as a critical neuroprotective factor, and that is true from earliest life. It's not just those of us in our middle and late age who burn the candles at each end, who need to worry about sleep. It's about setting the scene from early on. And of course, there are the other factors which might enhance inflammation, which is bad for your brain, things like infections, but also stress, mental health disorders, which may impact the set point in one's brain and push it or pull it in one or other direction. And then again, one can also have individual discrete impacts. So things like alcohol exposure, which may be more of a factor in prenatal life, exposure to HIV, a particular episode of traumatic experience or a particular infection, but many of these things, as I've said, are transversal. So how does context matter in our environment, in our region? This is the area where the story plays out. In Africa, south of the Sahara, and as you can see, this area, although certainly we are not the biggest continent, we have one of the richest diversities of climate within this region, flora and fauna. We certainly have huge numbers of different languages and culture, and so unlike the kind of gross generalizations which are made about this region because so little work is done here. Africa is not one place. We've got, and I'm preaching to the converted here, so I don't really need to get so excited. Africa is a rich tapestry of amazing cultures and climate and languages and peoples, and we need to be able to celebrate that, but we also need to be able to understand it, to be able to support our children as they grow into independence. What we have here at the Neuroscience Institute is we have an absolutely fabulous institute, as you can see up in the left-hand corner. Thank you, Graham and Jackie. But it's a very, very sophisticated institute. We've got amazing neuroimaging facilities. We've got EEG facilities. Ernesto, who's sitting here, spearheaded our MRI capabilities here. These are facilities which are next to many other world-leading organizations who are doing this kind of work. And yet, many children who live just 20 minutes down the road live in informal housing. They may not have running water, may not have electricity, and so we have this juxtaposition of very sophisticated infrastructure and research capabilities and populations where many of the conditions of poverty and of socioeconomic risk are at play. And these might include things like HIV infection, but also might include many non-communicable diseases, which include developmental delays and mental health concerns as well. This is a very striking image of electrification across the world. And as you can see, as a whole, Africa is very under-electrified. And I think this probably is without Eskom's antics. But even if we were working, if our lights were on all of the time, really South Africa has the lion's share of the formal infrastructure in the region. And so while we have the responsibility to really be able to answer some questions which do have a regional relevance here, this is not the end of the story, and we need to think further. So why is it important to look at children, and what questions are we going to be asking? So Africa is one of the last continents which has a growing population, an accelerated population growth. And as a result, that means that we have a young population. As you can see in the in this chart here, where the majority of the population is in fact youth, compared to the global north, where they have an aging population, and much of their focus is on conditions that are for an aging population, which means that they are slightly less interested in things which are most important to us. So we have to lead the way on things which are important to our region. So if we look at the population projections, children will remain the major focus of Africa, and Africa will be the main focus of the world's children. In 2050, of Africa's projected 2.9 billion population, 1 billion will be children under 18. So that's a third of the population. And children in Africa will account for nearly 40% of the world's children under 18 in 2050, rising to a staggering 49% of the world's children by 2100. These are just projections, but the point is clear that we have a big responsibility to get it right. So what about genetic variation? Can we understand some of the intrinsic or genetic factors that may underlie neurodevelopmental conditions? So my clinical journey is based in children, in caring for children with both acute and chronic illnesses. my main focus has been on children with neurodevelopmental and neurological conditions, which include things such as autism, global developmental delays, epilepsy, and cerebral palsy. And it's widely acknowledged that many of these conditions have a strong genetic component. However, environmental risk plays a large role in how children present differently. And in addition, there are many more preventable secondary causes, such as a child with CP following on from meningitis or intellectual disability secondary to cerebral malaria. So all children, regardless of the presence or absence of a neurological or developmental disorder or condition, grow up in an environment which may either support their developmental potential or put it at further risk. I turned my attention to thinking about how factors that are common in our environment may impact the development of all children and how this may be used to explore avenues and age windows for prevention or intervention. This slide gives you a sense of the global population of children, of individuals with intellectual and developmental disabilities. And as you can see, the greatest proportion is in fact in our region, certainly in the lower middle income country regions. Globally, India is very well represented, but in terms of actual population, Africa is very, very heavily represented. So we are disproportionately burdened with neurodevelopmental conditions. But very little is known about the genetics of neurodevelopmental disorders in children of African ancestry. We've done a current study on genetic variation in neurodevelopmental disorders in African populations, and by African I mean people living in Africa, whatever their ancestry and background, with my colleague Amina Abubakar, Charles Newton, and Elise Robinson. And we have two cohorts, one in Cape Town and one in Nairobi and in Kilifi in Kenya. And this gives you a little taste. If we compare the children who present to our clinic, where we recruited children in the first instance, the proportion of severe symptoms which children presented with. So, for example, if they presented with autism, did they also have epilepsy? Did they also have intellectual disability or developmental delays? Did they also have other mental health disorders or conditions? And compared to an American population sample of children with autism, we are much further down the list of additional factors. And I think the reasons for that are many. One important reason is that access to care in an environment where people have less resources, and where there's a focus in the medical services on infectious diseases and acute conditions, it's much harder for people to access care for more chronic conditions. It's expensive to come in, and developmental conditions are stigmatized, heavily stigmatized. And so many children who have milder neurodevelopmental disorders, who may well benefit from intervention, are in fact not being seen in our medical services. And it's not to say that our service hasn't grown exponentially and over doubled in size in the last few years in terms of our fire hose of referrals, as Mark likes to refer to it. It's not that we're not seeing children, it's because the burden is huge and we're not seeing all of the children. So what about the genetics? Here you can see how few children. So this is a global database. This is the representation of ancestries in genetic databases worldwide. And you can see that the big thick red bar at the top is the European ancestry populations, and Africa is a small little slice at the bottom. And not only is it a small little slice at the bottom, but it's a small little slice which hasn't really grown hugely in recent years. Now, we hope to be able to change that, but as yet, it is still in its infancy, relatively speaking, in this area. These are preliminary results, in fact, from our neurodev study, and this plot gives you a sense of how different two children are from each other in terms of their genetic similarity. And you can see the purple bar again here is children of African ancestry, and they're far out on a limb, as in the genetic variation in African ancestry populations is the greatest of the world in the world. And because and if we're not studying it, then we're not able to contribute to global databases. We're not able to participate in initiatives that help understand children and individuals at a genetic level. So we've got a big job to do, but we're getting started. So indeed, when we analyze these samples, of the first 400 odd children diagnosed with developmental conditions who we did genetic testing on, only 23% could be identified with a genetic variant that could be assigned as being likely causal. And similar studies globally generally result in a pickup rate of 30 to 40%. Karen might correct me, but I think it's in that range. So what about environmental impact? So I'm coming back to this. We have a myriad different environmental conditions, environmental factors which may impact the developing brain. I'm going to talk to you about a few examples, and the reason I've chosen them is because it may seem like a depressing story to say that we have an environment of high risk. But actually the opportunity we have here is to understand that risk so that we can design interventions that are relevant and that are correctly placed in terms of timing and effectiveness. So the first condition was HIV. As a pediatric neurology registrar, I was seeing many children who were HIV infected, often with severe neurological conditions. Professor Wilmshurst, under whom I was training at the time, encouraged me to pursue developing a service for these children, and Kathy Walker and I started the Pediatric HIV Neurology Clinic at Red Cross in about 2008. We diagnosed and managed some hundreds of children living with HIV who also had epilepsy, global developmental delay in growth and motor disorders. And when I qualified as a pediatric neurologist and took over leading the developmental pediatrics service in 2009, I continued in this clinic. But amazingly, by 2015, the successful rollout of antiretroviral treatment had had a massive impact on reducing mother-to-child HIV transmission. Alongside the earlier treatment of children who were HIV infected, we saw a dramatic drop-off in children with secondary neurological complications of HIV, and we were able to integrate services for those children into the general clinical care environment, which was a success. But in supporting these children, we recognized that there were many other factors in their environment that were putting them at risk for worse outcomes, as I noted earlier. And what I mean by this is that if you receive a knock during your early development, when your neural networks are developing, the trajectory of your development is going to be affected in the future. However, you can still reach your potential given an enabling environment. However, what we were seeing was that other factors in the environment were putting these children at risk for far worse outcomes, well below their potential trajectory. And this included considering children who were uninfected themselves, but who had mothers living with HIV. In my developmental clinic, I started paying attention to the large burden of children with behavioral and developmental conditions associated with substance use in pregnancy as well. And this included children born to mothers who had used methamphetamine and those born to mothers with alcohol use in pregnancy. And I began building on the huge body of work done by Professor Colleen Adnams, who had led work locally on establishing the prevalence of fetal alcohol spectrum disorders, developing valid diagnostic tools, and providing interventions for affected children. She had also highlighted the importance of considering cultural and economic factors in FAST research and management, and I learned a lot from her. During this time, I had the privilege of being introduced to the Drakenstein Child Health Study, a seminally important birth cohort study initiated by Professor Heather Zaar and Dan Stein, and this cohort comprised 1,000 mothers and their children residing in the Drakenstein district beginning in 2012. I was invited to be part of the team working with the study. In particular, my focus was to understand what was important about environment in our context for children's brain health and development at a population level. So moving from the clinic into a more population level, recognizing the importance of the early life period in terms of laying down foundational networks and identifying opportunities for interventions. I was interested in the underlying neurobiology of some of these exposures, and focused first on establishing whether the impact of prenatal alcohol exposure could be detected in the first weeks of life using neuroimaging approaches. And under the supervision of Dan Stein, I completed my PhD, which showed that the impact of PAE or prenatal alcohol exposure could be detected in very early life in the structure and the major pathways linking important regions of the brain, as well as their organization, and that this correlated with early developmental outcomes. But as we've seen before, brain growth and maturation happens at its greatest intensity in the first 1,000 days from conception to 2 years of age. And I recognize that to understand this impact more fully, I'd need to look at where and how development was taking place or being influenced in more detail from a time increment perspective, i.e. we needed to image children across smaller time increments over these first 1,000 days. So as I mentioned earlier, Professor Ernesta Menke spearheaded the acquisition of the cross-university research MRI scanner, initially housed at Tygerberg Medical School and subsequently moved to its current location here at the Neuroscience Institute. However, while we had both imaged newborn babies at the time, no one in the region had tried to do MRI scans on children between this age and school age. A few people in other parts of the world were imaging children in this window, but none in our region. But I'm a pediatrician and I'm not afraid of small children. So I knew it was important to look at this period of life, and I believed we could do it. I persuaded the Research Ethics Committee that we could do this safely, that I was a responsible pediatrician who made good choices, and the Tygerberg Radiology Department to allow access to the research scanner in the evening, which was no small feat, when children are more likely to fall asleep, and set about scanning 2-year-olds. Now, who's been in an MRI scanner themselves? As you can see here, it's a dark tunnel. It's claustrophobic. You have no sense of time. It makes loud, scary noises. So the chances that you're going to get an awake 2-year-old into that or 3-year-old into that scanner is limited. But you know, in research, you obviously can't sedate or anesthetize a child. It's not ethical. So we had to do it while the children were sleeping. And this is the one child, hey, Catherine, the only child who went into the scanner awake at age 3. And she looks pretty happy about it. We had to take a picture of her. That's for real. But the rest had to be asleep. So I remember on the first night sitting in the sort of dark back end of Tygerberg Medical School in a near empty imaging unit in the early winter dark. I was properly worried that the children would be afraid and that being in the scary dark and echoey building would upset them and that they wouldn't want to sleep and that it wouldn't work. But it turned out that the key to this, as for any childhood issue, was the mums. And making the mothers feel comfortable meant that their children felt safe, and after a warm supper, they slept. So now that I knew that we could scan children at this challenging age, we then, over the course of some months, scanned 200 children who'd previously been scanned as neonates, so that we now had 2 MRI time points where we could study along the timeline, and eventually we'd scan again at 6 years, Leila, completing this early leg of our longitudinal study. This shows us the scans of the children at 2 years of age, which Catherine did the publication on as part of her PhD. So having shown that brain imaging in very early life is feasible, how have we used it to answer questions that are important in our region? So here's Red Cross, and I always hold that the reason that we answer relevant questions is because we have a clinical footprint, and being in the clinic and seeing children who have who get sick, who get better, children who have developmental disorders and children who don't, we make sure that we ask the right questions and we keep the questions relevant. So the first example I'm going to give you is the children who are HIV exposed but uninfected. So this is an adaptation of a figure that Catherine often shows, which shows that over time, the number of children who are HIV exposed but uninfected has grown and continues to grow. That is, of course, good news because it means that they are exposed to HIV but not getting HIV infected themselves through vertical transmission. But they are nevertheless exposed, and they are also exposed to antiretroviral agents. And again, as part of her PhD thesis, Catherine has been able to show that the cortical thickness changes associated with HIV, children who are HIV exposed versus those who are not exposed, and that this partially explains impairment in language development. Now, the reason I've put this in is A, because it is good news that the children are not infected, but B, because some of the sub-analyses of this work have also shown that good immunological health in the mum makes a big difference to how children are affected or not affected. So, and the questions which we are still in the process of answering is which of those antiretrovirals is the safest for the developing brain, given that we know that we'd like to preferably try and avoid any drugs in pregnancy. So this is a job for us still to do because there are many millions of children still who are exposed to HIV, and many of them here in sub-Saharan Africa. So the next area of focus is maternal anemia. Now, anemia has been widely described as being associated with poor cognitive outcomes. But when is it important? When is it most important? And Catherine and Jess, who's now doing her PhD in this particular topic area, we've looked at the timing of anemia. So is it more important whether the mum is anemic during pregnancy or whether the child is anemic during early life? And what does that mean? And it appears in this first cohort that and given the limitations of any particular study, that the changes in the brain associated with anemia are almost all driven by the maternal anemia. So this is good news as well, because in a way, antenatal populations, mums in pregnancy are a captive audience. They come to care, and many in our country anyway, many mums do book. So we have an opportunity to intervene and get it right. Much easier than trying to capture young children and get them to have nasty iron medications. The last example I'm bringing here is again the story of longitudinal change. So this is back to the Drakenstein study and looking at the 3 time points that we now have, the neonatal time point, the 2-year time point, and the 6-year time point. And what these graphs represent is change over time. It doesn't matter what, it's the superior longitudinal fasciculus, but it doesn't really matter what region it is. But you can see that the change over time that happens between the neonatal age and 2 and the change over time between 2 and 6 is step change different. So having done that, we realized, okay, so we're very pleased with ourselves for having imaged children at 2 to 3 years of age, but actually that's not good enough. We need to be doing imaging. We need to be looking at brain development much more frequently during early life. So now that I've demonstrated the importance of prenatal environment exposure, what happens after birth? Again, I bring you back to this slide, which talks about sensitive windows, and I'm going to bring you to this period because we've got a cohort which we have just started and which Lionel referenced, the cooler cohort, which means to grow. And those children are just turning 1 now. So we've looked at them at 3 months and at 6 months, and we're just starting to get a sense of where they are at 3 months of age. And look at 3 months of age, one can actually get very beautiful images of and very refined data on what the pathways that are growing and developing in the very young brain. Are there other ways that we can measure the brain? This is an EEG cap. It's a, and this is what you get from an EEG cap. Electrical signal may look like a circus to everybody, but when you look at it on average over time, you can see that it changes very rapidly in the early months of life, as one would expect, because of the very iterative process. If you think about a child of 3 months versus a child of 2 years and the difference in the skills that they have over that period, it's not surprising that their brains are very active and changing over that time. So we're looking at the maturation of the EEG over specific areas which are which underlie the major skills of this period of life. So, for example, your visual cortex is undergoing major development at this time as you start seeing things and making sense of the world. And what we were looking at is we're thinking about what are the other things postnatally which are particularly important. So it may be the things which I've talked about before, but it may be other things as well. So we can capture environmental exposure in early postnatal life through a number of different ways. We've started to explore this in this birth cohort study, and in fact we can look at the microbiome, which is a range of viruses and bacteria which live in one's gut and are a reflection of your nutrition. They're in fact a reflection of your sleep. They are a reflection of what your mum was doing during pregnancy. It's hugely varied and very important. And what you can see here is microbiome from children from Brazil, from the UK, in Ireland, or rather from Ireland, they'd hate that, from Malawi, from South Africa, from Bangladesh, and from the States. And you can see they're quite spread out. But what you might notice is that Malawi is out on its own on the left. And if you look at, if we just take out South Africa and Malawi, we can see, in fact, that they are really, there's almost no overlap between the microbiomes of children growing up in these two regions. So it speaks again to the fact that we need to be thinking about each of these cohorts in a very carefully distinct way. Are there other things which are really important, which aren't generally captured? The mother-child interaction is a critical piece, and there are ways that you can take videos of mothers and infants just interacting with each other and code how predictable the mum's response is to a child. So when the mum smiles at the child, is the next thing they're going to do touch the child? Is the next thing they're going to do pass them a toy, pick them up, hug them? And it turns out that the predictability of mum's response to a child in that fine-grained way is the strongest predictor of the child's visual brain development, and that's the only kind of measure we have at 3 months. And it's early days, and we'll see what that brings in time. But it just goes to show that it's not just the usual suspects. We have to think about social relationships as part of brain function. I just bring up sleep again because sleep, I think, is the elephant in the room. I think it is something, again, that we have to understand in context. I think that a child going to sleep on their own in a room versus a child who goes to sleep on their mum's back or in a co-sleeping in a shared space versus in a kind of more nuclear family environment, that experience is going to be different. Is it good? Is it bad? Doesn't it matter? We'll get to see. So it's all very well to do this work and to publish it and to make it mean something out there in the world so that people take note of the things which are relevant to us and so that we can bring understanding of these conditions into a global world. But we need to be doing this not just single people here at the Neuroscience Institute, we need to be learning at scale. So this takes two forms. One is making sure that we have data at scale. We're able to contribute at scale. Now, this study, it was published in Nature, and it is a growth chart for brain volume over the lifespan. And as you can see from this map, most of the contributors were from the global north, with some representation from South America. And in fact, we did end up contributing to this, but it was fractional compared to the kind of global depth of data that was contributed. So we made up a very tiny piece. So we have to be able to do better than that. Now, how are we going to do that? MRI machines are expensive, and people, if governments are going to buy machines across this region, they're going to buy them for clinical use because they're sorely needed. So how can we do this differently? Again, I'll try our little girl very happily going into the large bore scanner, but most children do not do that. And it turns out that there's a little mobile MRI scanner, and we're very lucky to have one. It costs a fraction of the price. It doesn't need shielding, and it is much more user-friendly and much more child-friendly, much more person-friendly. It can only scan brains, but that's good enough. But obviously, it's like a low-resolution photograph. It doesn't give you quite the same amount of detail as a scan from the 3T scan, and you can't do the amount of detailed work. So it is a good thing that AI has come into its own in recent years, and that there are ways of doing scans on the same children in the 3T scanner and in that mobile MRI scanner, which we are currently doing, which allows us to scale the images so that they are able to better differentiate the different structures and regions. It's an imperfect solution. Doesn't do everything perfectly, and isn't necessarily aimed at lesional MRI, and that's maybe something which is more important here, where we have more infectious diseases and CNS infections. But that's why it's important that we contribute to these conversations, and we are indeed part of that network. And again, we're actually using these approaches, we're able to get very, very good alignment with volume estimations, even of small subcortical gray matter structures using the low field MRI. Beyond that, though, it's not just about the stuff, it's also about the people. And we're very lucky to have a new funded postgraduate network grant under Wellcome Trust funding, which will have us support 50 postgraduate students in the neuroscience of early brain development over the next 4 to 5 years. So we're excited to get started with that. So in summary, brain development is complex and iterative. The underlying networks for later development are impacted by a host of factors that begin before birth and continue well after birth. It's important to understand determinants impacting early development in different environments. What is true of factors in one context may be different to another. In order to best support the potential of children's development across contexts, we need to understand what are the more universal themes, but also what are the factors critical to understanding early development in our specific context and region. We can't do this alone. We need to build expertise, and we need to build scale. With that, I just want to say that this is an unusual moment where I get to say thank you to the community of people I've had the privilege of working alongside for many years, from the clinical staff and trainees to the postgraduate students, the staff who've worked on research studies, and everything in between. I've learned as much from you as you have from me. I also want to thank the Neuroscience Institute team, who have really led the vision to making this institute have the potential to offer these kind of insights to the world. And a huge thank you to Graham, to Jackie. And I want to mention Dan again, who was my PhD supervisor and who had a really important mentoring role as well. A thanks to collaborations, particularly to those who do the hard work in our region. It's hard to do exacting science in our region, and to those collaborators I hold a huge debt of gratitude, and to those other generous collaborators beyond as well. Thank you to the funders, and probably most of all, thank you to my family. This is a picture of Sophie sending out some paper boats when we said goodbye to my dad some years ago. And so I just want to thank all of you for being here and for your support. Thank you.
Thank you very much, Professor Donald. Let me, though, call on Professor Graham Fegan, the Director of the Neuroscience Institute, to deliver a vote of thanks. Graham.
So thank you and good evening, Vice Chancellor, Deputy Vice Chancellors, Dean, friends, guests, Maribel, Kirsty's mum, and her family. It's really an honor to propose this vote of thanks for this wonderful lecture we've just heard from Professor Kirsty Donald, a real tour de force on context matters, risk and resilience, brain development in early life. It was a wonderful lecture, Kirsty, just delivered with your characteristic warmth, generosity, modesty, incredible humor and passion for everything you do. And I think everybody in this room would really like to thank you for the experience of being part of this. You spoke about a journey, and it was a journey through some complex stuff, the science of brain development and the impact of all sorts of factors, some good and not some good, on brain development. But ultimately, it was a very human story of discovery. And I think all of us really felt your passion and your sense of really engaging with the problems that our Dean referred to, that all of us in the spirit of social accountability need to address here in South Africa. So I just want to touch on a few of the things that you covered, and then I was given 10 minutes, and I'm going to end off with a few reflections from the people who know you best. So you started by describing the trajectory of human brain development and the interplay of our inherent capabilities and the environment in the timescale of early development. And you highlighted the extraordinary fact that we're building our brain as we're using it, which is really quite extraordinary through this experience-dependent synapse formation. As stated by another famous Donald, I think one day probably the less famous Donald Hebb, the Canadian neuroscientist, neurons that fire together wire together. And I think you've shown us very powerfully how important that concept is. But also I think showed very convincingly that to be our best selves, we need the best start we can in life and the best foundations. And in that respect, context is just so important. I think you spoke very powerfully about the importance of context in our situation in Africa, and not just from the point of view of adversity and risk, but also the incredible opportunities for understanding resilience and ways in which we can actually do well in the face of adversity. I think one of the key messages that came across is the extent to which, confronted by sometimes complex and difficult problems of low and middle income countries, we also have this juxtaposition with not just incredible technology, but incredible people, incredible expertise, where we can do really world-class science that not only addresses the problems that confront us, but actually contributes to knowledge globally. And I love the way you said, not just about the stuff, it's about the people. And I think that really is emblematic of the way in which you go about your research. So you spoke about how context matters in the sense of genetic variation and also the environmental factors that come into play. And you highlighted two very significant disparities. The one disparity, the lack of representation of African populations in genomic studies. And you also spoke about the lack of understanding of neurodevelopmental disorders and the extent to which so many in Africa are considered idiopathic, which obviously just means we haven't really looked in the right places. And I think today's lecture leaves us in no doubt that you're well on track to making a serious effort to address these disparities. And as you said, we've got a big job to do, but we're getting started. So thank you for doing that, Kirsty. Then when you spoke about the environmental factors, there were two things that really, I think, resonated. The first is you described a series of research questions of increasing complexity, which kind of followed the trajectory of your career. From the early days when you were working with Joe, confronting kids with HIV, infected with HIV, and the neurological problems that they had, and engaging with individual patients and trying to understand what was going on. But then once you'd qualified as a pediatric neurologist and your work as a developmental pediatrician, kind of starting to think on a bigger scale at a population level, the incredible opportunity to work with Professor Zah and Professor Stein on the Drakenstein birth cohort study, which is an extraordinary resource to understand brain development more broadly at that kind of population level, and then looking at all sorts of adverse factors in a very scientific way, from fetal alcohol exposure, maternal anemia, HIV infection, and then later down the track, sort of HIV exposure. And in reality, birth is just one event in the trajectory of brain development, and sort of shifting from all these prenatal factors to looking at postnatal factors, the microbiome, social relationships. It's a beautiful and I guess unending story that you're contributing to in so many powerful ways. But it wasn't really just about science, and I think in using the term kind of learning at scale in Africa, you perhaps underplayed even your own contribution and the huge amount of work you've done through Deltas 2, committing to training something like 50 postgraduate students through a single research grant that is really going to start significantly enhancing capacity to do really meaningful neuroscience work in Africa. So, there's no doubt that your approach is highly collaborative, building partnerships, and it's really just an incredible privilege to kind of be part of that journey with you. So, inaugural lectures are just amazing events. It's kind of the pretty much only time in your career when you stand at the lectern and you see your family and your close friends, your colleagues, your teachers, your students, people you've never seen before. It's amazing, and you kind of have to deal with all this and give a lecture. They're unique events. I think today we kind of took a new step in the kind of development of inaugural lectures in introducing pre-drinks. So I think that's quite a cool, going to become quite a cool NI tradition. But I wanted to just end off, if I may, Vice Chancellor, with a few comments from what you refer to as the community of people around you. And I'm going to quote very briefly from your mentors, from your colleagues in the Neuroscience Institute, and from your family. So in terms of your mentors, so you mentioned Professor Wilmshurst as the mentor that trained you in pediatric neurology, who referred to you when I called her earlier as a clip-springer. Said you're the only fellow she's ever had who is not only a proficient rock climber, but has abseiled the inside of Cavendish Square. And Joe described you as the fastest airport walker she's ever traveled with. And on a more serious note, speaks about your resilience, your calm and grace in situations of stress. And I think grace actually is just a word that resonated deeply. And Dan, your PhD supervisor, sends sincere apologies for being away at this time, but describes you as one of the most amazing individuals he has had the pleasure of supervising. And Dan, I think, has probably supervised more PhDs than anybody else in this university. And he says he learned more from you than he believes you did from him, which is very gracious. I think we all feel the same way. And Professor Charles Newton, probably your closest collaborator, PI on the KEMRI Wellcome Research Program in Kilifi in Kenya, who said it's hard to encapsulate the contribution you've made to neuroscience in Africa. What has been particularly impressive about Kirsty's research is the wide array of methodologies that she has used to study the developing brain, from genetics to neuroimaging, as we've seen very beautifully today. And that this research is grounded in vast clinical experience that makes it really relevant. So well done for that, Kirsty. from the Neuroscience Institute. And I think the first time you really kind of took the lead in a big way in the NI was 2016, when we had our first meeting with Wellcome Trust, who were really important funders that we really had to find a way of engaging with. And you took responsibility for kind of building that relationship. And I think it's been probably the single most significant relationship we've had in terms of engaging with major research funders. And following a strategic review, you were the obvious person to take up the role of deputy director. And you contributed in so many ways as part of the leadership of the NI, not just in kind of leading a very consultative process of developing our research strategy, but that very, very powerful showcasing African neuroscience process that you led for the Wellcome Trust. Your colleagues in the NI describe you as incredibly kind and approachable, humble but brilliant students, and all your trainees just recognize that you always have time for them, and that will come up again. And usually a trip into Kirsty's office is accompanied by peals of laughter and tremendous scientific insights. And then finally, the Department of Pediatrics and Child Health, I really want to acknowledge, particularly the HOD, Professor Ritani Muloiba, who's sadly also not here this week, but just a serious word of thanks from all of us in the NI for kind of letting us borrow Kirsty, who's been such a big part of building the NI. But beyond academia, I just want to end off with a few words from Kirsty's family. So Rob described you as very adventurous at home in the mountains, but you've had to adapt to an aquatic environment since marrying him. Speaks very highly of your ability to adapt under those adverse circumstances, risk and resilience and all that stuff. But he did very, very cunningly make sure that your honeymoon was at Okavango, where there's not a mountain in sight. And definitely you'd more happily tangle with the hippo than with the mountain with you in the lead. And then in the words of your two daughters, so Sophie, of course, referred to your prowess as a hiker and extraordinary cook, but pointed to your very creative Waldorf upbringing and your amazing artistic abilities, which we've got a little kind of project for you now in decorating the NI. And Olivia spoke about how you somehow managed to be everywhere at once, but never make any of your family feel that they've been forgotten. And Olivia goes on to say, I'm always amazed at the sacrifices Mum makes in her work to be there for us. She's moved overseas flights to a conference so she can come to a school play, and regularly does, I don't know if I should say this in public, but anyway, regularly does a morning school run while listening with one ear to a Zoom meeting. And to the other with us reciting Afrikaans mondelings or going over the parts of the cell for the umpteenth time. Perhaps most impressive. And you just gave us a little homily about sleep. Apparently you get up at 5 every morning to get your work done so you can be available for your kids in the evening. So that's pretty cool. And then from those who've known you longest, other than your mum, of course, Anna and Jani. So Anna described your career as your destiny. Said Kirsty's doing the right thing for her and doing it with the greatest capacity, the greatest commitment, and the greatest love and compassion. And she describes your ability to kind of be in the moment and present with people, which I think is a very, very special attribute that you have. And finally, Jani recounts an anecdote, which I hope you'll forgive me sharing in public, that you've always had an investigative scientific mind. When Kirsty was about 4 years old, she became interested in discovering whether she could cut flesh. She calmly set about doing this by finding a pair of scissors. I don't know if you got a grant before. It was probably the only unfunded research you've ever done. But found a pair of scissors, called Jani over, and promptly took a snip out of her tummy. So apparently you remember the incident with a mixture of horror and wicked delight. And Jani's got no memory of it. Believes that she wasn't scarred for life, at least not by that particular incident. So I think we can all agree that what surgery has lost through Kirsty's own developmental trajectory, neurodevelopmental it's far too complicated for a surgeon. Neurodevelopmental paediatrics is gained. As he said, a pediatrician is not afraid of small children. Indeed, all of African neuroscience is gained. An African neuroscientist not afraid of big ideas. Thank you, Kirsty.
Thank you very much, Graham. So, ladies and gentlemen, I think we've had a demonstration of what happens when you take a constellation of considerations from children, development disorders. You add a context to it, a social context, African context, and then you bring deep scientific thinking and investigation to bear on all of this. This, I think, is what we've seen from Professor Donald's lecture tonight. And through that, we extend our understanding and we make a difference. So it really has been, I think, a truly inspiring lecture. And if ever we needed any evidence to the effect that you are a professor, you really are a wonderful professor. Thank you very much, Professor Donald. Thank you also to our Dean, Professor Lionel Green-Thompson, for his introduction to the speaker, and again to Professor Fegan for his wonderful vote of thanks. Enjoy the rest of the evening. Thank you very much for being here.